Okay, so in this video, we will build our arithmetic that we can do with matrices. In particular, we'll talk about how we can add two matrices and how we can multiply a matrix by a scalar. So let's assume that A and B denote two matrices, M by N matrices, and this is important. They have the same size. So A and B have the same number of rows, M, and the same number of columns, N. Then we define the sum of these two matrices, A plus B. I'll just denote this as matrix C. It's going to result in a matrix that is the same size as A and B. So it's going to result in an M by N matrix. And we just add the columns of this matrix are going to be the sum of the columns of matrix A and B. So in other words, the ijth entry in matrix C is going to be the sum of the ijth entries from A and B. So we just add the entries in the ijth positions in matrix A and B to get the ijth entry in matrix C. So we're just going to add entry by entry. We define scalar multiplication of a matrix. So we're going to let R denote some scalar and A is still some M by N matrix. Then we denote this with R times A. And the way we define this is we're just going to multiply every single entry in matrix A by this scalar R. So the ijth entry in matrix C, which would be the result of this operation, is going to be this scalar R times the ijth entry of matrix A. And it's also worth stating that two matrices A and B are equal to each other. First of all, they need to have the same size, the same dimensions, the same number of rows and columns. And secondly, every single entry in matrix A should equal the same value of that same corresponding entry in matrix B. So let's take a look at an example. Let's consider the matrix A, which has 2 rows and 3 columns. So this is a 2 by 3 matrix. And we're going to add that to matrix B, which also has 2 rows and 3 columns. So, okay, these two matrices are the same size. That's great. We can add them. It's worth noting here that these two matrices are not equal to each other. They have different values in the first entry, so that would be enough right there. So let's compute the 2 times matrix A minus matrix B. So we can first calculate the product of 2A, which is just going to be the result, what I get when I multiply every entry in A by 2. So that's going to give me minus 2 times 2. And then the next entry, I'm going to take this 2 times this 0, and that gives me 0. Then I take this 2 times that 3, and that gives me 6. And then I've got 2 times 2 is 4, 2 times minus 2 is minus 4, and 2 times 1 is 2. So we're just multiplying every single element in this matrix by 2. And that's what we get as a result. And now if I want to subtract matrix B from this, we do this entry by entry. So that means this first entry, I'm going to take the minus 2 minus the 1. And then the next entry is going to be the 0 minus the 2, and so on. And then we have, in this case, a negative applied to the minus 1. That's where this plus 1 comes from. And then I would have a 4 minus a 0. So, excuse me, that's a minus 4 minus a 0. And then a 2 minus 5. And then we can simplify that. We have a minus 3. We have a minus 2. We have a 0. 4 plus 1 gives me 5. Minus 4 minus 0 gives me minus 4. 2 minus 5 gives me minus 3. So in the end, we wind up with a matrix of the same size, a 2 by 3 matrix, which I've written below. Okay, now that we've defined how we can add matrices, multiply a matrix by a scalar, let's comment on some properties that these operations would satisfy. And these operations pretty much follow from these properties holding when we do addition and multiplication of just scalar numbers. So the first property here is saying that addition is commutative. It does not matter which order I add these matrices. A plus B is equal to B plus A, and that's because when this is defined by adding entries together. So if I take Aij plus Bij, it's the same thing as Bij plus Aij because addition of numbers is commutative. The next property is stating the associative property of addition. So this is saying if I'm adding three matrices, and this is telling me to first add A and B and then add that result to C, that's going to equal, if I instead do this addition in a different order, I first add B and C, then I take A and add it to that result, we'll wind up with the same answer either way. And then this follows from the fact that addition of numbers is associative. Third property is when I take A, and this 0 here is denoting a 0 matrix, which is m by n. So it has to be the same size as matrix A in order for this to be defined. But adding 0 everywhere is not going to change any of the entries in matrix A, so I get back exactly matrix A. Now we can talk about what happens when we combine operations, addition and scalar and multiplication by a scalar. So this is a distributive rule which says if I take scalar r times the sum A plus B, this is equal to r times A plus r times B. And this property follows from the distributive property of numbers. And here is a similar looking distributive property, and that is if I have r plus s adding this scalar times A, that's the same thing as r times matrix A plus s times matrix A. And the last property is dealing with associative property for multiplication here. So if I take the product of s times A and then multiply that by r, that's the same thing as if we were to first multiply the two scalars r and s, and then multiply that by matrix A. So I would encourage you to go ahead and try and verify these properties. They all should follow from properties that we know for addition and multiplication of just individual numbers. And I just want to close this video before we jump into matrix multiplication in the next video, just discussing how you could do this arithmetic in Python. And so I have some code that I posted on the left, and I will put a Python notebook, a Google Colab notebook, in the comment below this video so that you can play around with this file yourself. But we can load the NumPy library because we want to work with arrays. And so here I'm entering the previous problem that we solved on the previous slide. So here was matrix A from that problem. Here I've loaded matrix B. I have these decimals because I want all of these values to be calculated as decimals and not integers. And there's a function in the NumPy library called add. So that is going to add two arrays in the appropriate way. So this line of code is doing a couple of things. It's saying, let's multiply 2 times the matrix A. So first of all, if I want to multiply a scalar times a matrix, I just use the regular multiplication symbol. In Python, if I were to do 2A, that's not going to be defined. So Python needs an operation between two different objects. So I have the object, which is the number 2. I have the object, which is this array A. And if I want to multiply them, I need to indicate exactly that. So this is going to understand exactly what you want to do. You want to multiply every element of A by 2. And now we're going to add that result to A with the matrix minus 1 times B that I can write like this. And I'll just say that we could have done this like there's many ways to do things. We could have used the NP subtract function instead. And in that case, it knows the order matters here that I enter things. So it's going to take this first thing minus this second thing. I also could just use the regular operation over here. I would caution you on this last method just because things aren't going to work as nicely when we're doing multiplication. So here, if I want to add arrays, I'm going to do NP add. And it's worth mentioning that down here is the output of this operation, which matches the arithmetic that we did on the previous slide. So while you're practicing, these are new operations, particularly matrix multiplication will be new. I encourage you to not just use Python. It's great to use Python to check your work, but while you're learning this, I would encourage you to get your hands a little bit dirty and do the operations yourself and just use Google Colab as a way of checking your work.